Hi there, welcome to the King Tutorial class, and welcome to another episode of Lasustech assignment question. Okay, this is part 2, and this is question 10. Now, let's factorize the following A, B, C, D. These are all quadratic or polynomial expressions. Let me just put it like so. They are all polynomial expressions. And for you to factorize them, you need to have a view of how the solution is going to be, or how the format is going to be, that's factorized form, before you proceed to solve the question. Now, what will give you that idea? What's the highest power of the variables here? There's 2, the highest power is 3, the highest power is 6, the highest power here is what is 4. Now from there, how do we then solve? If you recall, before I started treating the questions in Lasustech assignment question, because I already went through the question to see how it's going to be, I had to create videos on how to factorize polynomial expressions from order 2 down to order 6. So if you've not watched the video, do it to watch the video before you launch into this proper. Now, solving this question now seems like what? For a question, we have what? A squared plus b squared plus c squared minus 2bc minus 2ac plus what? 2ab. Now, recall. For ordinary a squared plus b squared, we say it's the same thing as what? A plus b all squared minus what? 2ab. This I have a squared, b squared, c squared, and then addition. So it means for a squared plus b squared plus c squared, it will be the same thing as what? A plus b plus c all raised to power 2 minus 2ab minus 2ac minus 2 what? bc. That will be the expression. That is, if I expand this and I subtract all this, I must get this back. As simple as that. Now, let's call this star. If this is star, what does it now mean? Put this new expression into star wherever you see a squared plus b squared plus c squared, so you can then continue. Also want to factorize it. Now putting this expression, or putting, let me say, star prime, put star prime into star to obtain what? So this, only these three, is the same thing as all this, so let's rewrite it. That becomes what? A plus b plus c all squared minus 2ab minus 2ac minus 2bc. What remains up here? What remains is what? Minus 2bc minus 2ac, then plus what? 2ab. Now looking at it, this cancel themselves out. What remains? A plus b plus c all squared minus 4ac and minus what? 4bc, if you pick your like terms properly. Now from here, let's now factorize finally to have what? A plus b plus c all squared minus 4 or minus 4c into what? A plus what? A plus b. So this is the factorized form of what? This is the factorized form of what? This expression for a question. As simple as that. This is factorized. Now for B question, before I solve B question, let's look at it. Before I solve this question, I would have to first solve this question, so you can have the idea of how this one would be after I finish solving this question. Before D, let's solve C's question. A raised power 6 minus B raised power 6 minus B raised power 6 is the same thing as what? A raised power 3 all raised power 2 minus B raised power 3 all raised power 2. If you watch the video, you know what I'm doing just at this place. Or if you know your law of indices very well, then you should just know what I'm doing here. Now this is the same thing as A raised power 3 minus B raised power 3 all raised power 2 minus, oh, this is minus, so this becomes plus 2a cube b cube then. So this is the expression. So it means this is the same thing as this. So this is the factorized form. As simple as that. Then for this question now, which I want to solve first before solving that of B. This question says what? Factorize this. A raised power 4, a squared, b squared, b raised power 4. Okay, a raised power 4 plus a squared b squared plus what? B raised to power what? 4. Now look at this properly. This is the same thing as a raised to power 2 or raised to power 2 plus ab or raised to power 2 plus b raised to power 2 or raised to power what? 2. Now the new highest power is what? 2. So I can say that this is the same thing as a squared plus ab plus b squared all raised to power 2 minus, now what am I trying to do here? Just as I got this factored form here, just as I got this factored form here in those other videos that I've done before, I'm using the same idea here, to solve for this. I'm trying to make them in the same power, so I can just generalize the power, then subtract what will remain, such that if I expand this and then subtract this that remain, I must get this back. So I'm trying to factorize this. How will it be? That's what I want to do now. So in this case, what do I have? I reduce this to this, which is the same thing. This now is the same thing as what? This minus something. Okay, these are still the same thing. I now want to factorize this or this, whichever I want to factorize. But I want to factorize this one because this is the one I can easily see, after breaking this one down. So if I expand this, means if I expand this one, what will I get? What I will get is from what I did before. Let me just bring in the paper for you guys to see. If I expand that, I got this. So let me pull it out. That's a raised to power 4. I'll come back up. That's a raised to power 4 plus what? 2a cubed b plus 3a squared b squared plus 2ab cubed plus b raised to power 4. Now I'm writing this out to show you something. Now I want to make it such a way that what? It will be this one all squared minus whatever remains. Expanding this gives us this. Okay, so it means if I was to take out this, what will remain? If I was to take out this from this, what remains? Look at this. So that's a raised to power 4 plus a squared b squared plus b raised to power 4. Taken out already. So this gone, one of this gone. So what remains? Plus what? 2a cubed b plus 2a squared b squared, then plus what? 2ab cubed. Now you can see that we have more than one a squared b squared here, in this expansion, in the expansion of this. But I just need one. I just need one of it because of what I want to do to easily get my factored form. So what remains? What remains is all this. So it means I'm going to be saying what? This one squared, whatever I get, minus what? All this. Okay, so that's what remains then. That becomes what? Minus, let me bring all the like times down, minus 2ab. Okay, ab is common. 2ab. What then remains? If 2ab goes out here, it means what? A squared plus ab, then plus this is what? B squared. Okay, so as simple as that. So it means the factored form of this expression is the same thing as what? Is the same thing as this. So if you expand this and subtract this, you must get this back. That's what it means. Then finally, for B's question, B is actually the longest, because it's actually cube, and it took time, for me to also actually come forth with the solution, which is not complete. Why? Because of what I'm going to be telling you very soon. B's question says what? A raised to power 3 plus 8b raised to power 3 plus 27b raised to power 3, then minus 18ab. That's B's question. How do I then solve? Now first, you have to reduce it to something that makes sense. How do I mean? This is 3, 3, 3. Very good. Now you must consider the coefficients also. All we've been doing before, we've been considering the coefficients of all this. This is 1, 1, 1. So 1 square is also accepted. This is 1 square. This is 1 square. This is 1 cube. This is 1 cube. 3, 8 jare. This is 27. This is 1 square, 1 square. 1 raised to power 6, 1 raised to power 6. This is 1 raised to power 4. This is 1 raised to power 2. This is 1 raised to power 4. And 1 is the brother to any power relatively. So Let's now see the solution to this. Now this is cube. What's coefficient of a cube here? That's 1. 1 is the same thing as 1 raised to power 3. Very good. So I can say 1 raised to power 3, a raised to power 3 for some of us. 8 is the same thing as what? 2 raised to power 3, b raised to power 3. Then plus, this is 27, sorry, for my question here. Okay, so this is 27. So that's the same thing as what? 3 raised to power 3. This should be c raised to power 3. Okay. Then minus 18 a, b, c, actually. Minus 18 a, b, c. Don't mind me. Okay, so how do I then solve? It means I'm looking for a factored form that looks like a raised to power 3 plus, 2b raised to power 3, then plus 3c all raised to power 3. So I'm dealing with cube now. So it means the solution will be of the form a raised to power what? No, a plus 2b plus 3c all raised to power 3, because they all have power 3. So minus what now? Now let's look at what the expansion looks like after expanding. After expanding, I came to this page. I used a particular book before coming to this page. I then got to this point. From here I got here, and then I got the answer as what? I got the answer as this. This was the final answer. Now I got it as all these long guys here. Now, what am I looking for? I'm looking for the factored form of what? Of this question. Now, if you see it very well, if you see it closely, I reduced it again, and I got all this here. So I got a raised to power 3, 8b raised to power 3, 27c raised to power 3. Very good. 18 ABC from 36 ABC divided by 2. 18 ABC, then plus the rest, plus the rest, and so. Just like I did for this other one, I reduce it to 2. That's a square b square plus 2a square b square. That's why I can give that's why I could give where is it now? That's why I could give this guy 1, and then okay, so now let's just continue straight up. What's the idea now? I got this, got this, got this. Very good. This one now, this is positive. If I say let me change to negative, it will be impossible. Why? Because the sign that came with it was positive, and it will be difficult. For this case, this was easier. Why? Because this is positive already. And then my question was what was my question? My question was this that I already cancelled out: a raised to power 4 plus a square b square. So the expanded form of this gave me all this, and it came in positive also. So what am I trying to say? I'm trying to say that this one came with positive, and what I'm looking for was negative. Okay, now say let me now try the one of minus. That is a raised to power 3 minus a minus 2b minus 3c, because this is the expansion of a plus 2b plus 3c. Now all this one I put on top here are for the negative. If I expand with negative, I'll still get a raised to power 3 plus 8b raised to power 3 plus 27c raised to power 3. But the issue was now that of this. The rest will still be the same thing, or similar. The issue was now this. In this case, what happens here is that what? One of the ABC will cancel one of the ABC because they are the same thing all through. What now remains? What remains is 12 ABC, which is this. That's what remains. If 12 ABC remains, I'm looking for 18 ABC. And I'm looking for 18 ABC, I'm looking for negative. This is still positive. So this question relatively as usual, and that's my conclusion to this question, or to the answer to this question, like so.